Hello chemistry kids, here we go. Let's talk about sig figs today. We're going to talk about this one. It's going to be just about sig figs, and then we're going to move through this worksheet and maybe it'll help you guys out a little bit. First of all, significant figures. What are they? There's three rules you need to follow in identifying significant figures. First rule, all non-zeros count. Okay, so obviously non-zeros would be anything from 1 to 9. All right, so 1, 2, 3, 4, 5, all that stuff. They're all non-zeros. So an example of a non-zero that we're talking about could be like 123 grams, and that has 3 significant figures because they're all non-zeros. All right. Another one we could say would be like go 1,198, and we'll go centimeters. That would be 4 significant figures because they're all non-zeros. All right, so that's your first rule you got to follow. Second rule, sandwiched zeros count. Okay, so when I say sandwiched zeros, that means they're in between non-zeros. So sandwiched zeros mean they're in between non-zeros. So an example of a sandwiched zero would be like 101, say grams. That would be 3 significant figures. Here's why. We have a non-zero, and a zero in between. That would be a sandwiched zero right there. Another example would be something like, say, 1,020.1. This one would be 5 significant figures because we have a 1, a 2, and a sandwich 0 here in between the 1 and the 2. And we have a sandwich 0 between the other 2 and the 1. The decimal doesn't change the sandwichness. Okay, so a sandwichness can carry across a decimal. So I could have, 20 zeros in between these non-zeros, and it would still count towards significant figures. So anytime they're sandwiched, and no matter how many zeros you have, they're going to be sandwiched and they're going to count. All right. And the last and third rule, we'll write over here. The third rule, which is the most difficult for most kids to get, has to do with written decimals. I hope you can read that. Kind of bad handwriting, but we'll get over it. So the key word here is written. Now all numbers have a decimal, but decimals are assumed. These ones have to be written. Okay, and it says, see what's the rule that goes with it? It says, end zeros count. When I say end zeros, I mean zeros that are furthest to the right in a number. So here's your example. 0.00, we'll put a 0 there too. 10. All right, we know that the 1 is a significant figure from rule 1, that where all non-zeros count. These guys are in front of the number. This 0 is in back, or at the end. These 2 are significant. The rest are placeholders. They just tell you what you're measuring to. So there's only 2 significant figures for this one. All right, it has to be, with a written decimal, it has to be the end zeros count. All right, and then if we even went further with that and say it was a big number, say 2010, all right, this would just be 3 significant figures. Whereas if I wrote 2010 with a written decimal, now we have 4 significant figures because we have a 2, a 1, a sandwich 0, and a written decimal, and here's my end 0, so the end 0 counts, so all 4 matter. All right, so there's your examples. Hopefully you can apply them. There's also one other exception you guys might run into. If you ever see a number with a dash over it like this, most people think that's a repeating thing. That means the number is repeating. In science and significant figures, that means that this number is significant. So this number right here, the 2 and the 3 count, this number is significant because it's got a line over it, and then that makes that 0 sandwiched, so therefore there's 4 significant figures here. All right. So now that we can identify some significant figures, we have to be able to use them in calculations. So if I'm multiplying or dividing, which is what we're going to do mostly, let's say I'm multiplying 123, say 0.5 grams times, let's see, times say 15. All right. So here's how it works out. You get your calculator out. Here's my calculator. Way to go, Texas Instruments. 123.5 times 15. That's my calculator answer. Hopefully you can see that all right. The 1852.5. That's my calculator answer. But my real significant figure answer for doing calculations, I go by my lowest number that I multiply by. So I have 4 significant figures in 123.5. I have 2 in 15. You go with your lowest number of significant figures to round to in this. So then I look at 1852, and I want to keep the 1. That's going to be significant. I want to keep the 8, the 8th spot, and that's going to be my 2 significant figures. So I look to the right of the 8 and say there's a 5. So tell me if I round up or down, and I round up because it's a 5 or higher. So this number is actually going to be 1900. 2 significant figures. Okay, you cannot be more accurate than your measurements. So if this one is the least precise with significant figures, you have to express that in your answer. All right, and if you look at that worksheet too, that'll help out a lot. So why are significant figures important? Because they maintain the integrity of a measurement. You can't be more accurate than the tool you're using. So it's all about accuracy and precision. All right, and when we're measuring things, how do we determine what's being used, or how do we determine how to go to the right number of significant figures? If you have a ruler, like for example this ruler here, these increments go by tenths. So if my increments go by tenths, I estimate to the next place, which is going to be the hundredths. All right, so you go one beyond the intervals. You estimate one more accurate, more precise than the instrument you're using. And that'll be your little run through of significant figures. Let me know if you have any questions.